Problem number 4. You have an aircraft carrier that launches an airplane off of the deck. Its initial velocity, of course, when it's sitting there is 0. It has a final velocity when it reaches the end of the ship. Of 62 meters per second. The acceleration is equal to 28 meters per second squared. And the question is, how long does this airplane get accelerated for? It means, the slingshot, what is this time that it's being shot off the deck? The formula that's best used is the first formula on page 88, which is velocity final is equal to velocity initial plus AT. We know everything except time, but as we did last week, we rearranged everything in class, and you nearly look at your formula sheet and you see time is equal to velocity final minus velocity initial over A. Just plug these numbers in. We call that plug and chug. I always like to get rid of anything that equals to 0. Just get rid of it. Just don't write it. No need to. So we have 62 meters per second divided by 28 meters per second squared. Notice how the meters cancel. The second cancels with that square. Second, since it's in the denominator of a denominator, moves up. And we land up with seconds. So by looking at the units, we know that we did the problem correctly. 2.2 seconds. Problem number 5. Now you should all know how to do this one because we were doing it as a lab in class. We have a school bus full of TF South physics students. They'll be getting on the expressway. We're going to say it's going to be traveling to the right. Its velocity initial at the head of the ramp is 0. And its final velocity we said was going to be 60 miles per hour. Well, what did I do to that? I, of course, converted it right away to meters per second. So 60 miles per hour is the same thing as 26.8 meters per second. I don't ever deal in standard units. I always make sure they're scientific units. Now, we said that by the time you started to the time you reach highway speed is 17.2 seconds elapsed. So let's redraw what we know. Velocity initial is equal to 0 meters per second. Velocity final is equal to 26.8 meters per second. And our time is equal to 17.2 seconds. Our x initial is equal to 0. Our x final is equal to, we don't know. No, I'm not sure why I wrote this above here, but x initial is equal to 0, if you look at the top by the bus. And I make a little mistake here. X final I write is equal to 0. It's not. I meant to write x final is equal to question mark. So the equation is x final is equal to x initial plus 1/2 velocity initial plus velocity final times time. And that's the formula I chose. We know everything except x final. X initial, of course, is 0. So x final is equal to 1/2 times, don't forget velocity initial is also 0, velocity final, which is 26.8 meters per second. Don't forget that was 60 miles per hour we had earlier. I changed it. And our time is 17.2 seconds. And we find our final position after 17.2 seconds is going to be 230 meters. So the ramp needs to be 230 meters long. Problem number 6. We have the Sears Tower, or currently known as the Willis Tower. And we throw a penny off of it. Our Y initial is going to be, let's say, 0. Our Y final, we don't know what it's going to be. But it should be a negative number because it's falling downward. Again, if we start at 0, we're going to say the top of the building 0, then the bottom of the building is going to be some negative number. What do we know? Our acceleration is negative 9.8 meters per second squared. The time it takes for a penny to fall from that height is 9.6 seconds. So let me rewrite what we know. Time is equal to 9.6 seconds. Acceleration is equal to negative 9.8 meters per second squared. Our Y final is equal to, we don't know, or our Y in general, or delta Y is equal to, we don't know. We can use the Cliff formula, which is Y is equal to 1/2 AT squared. Our acceleration is negative 9.8 meters per second squared. And our time is 9.6 seconds squared. Don't forget, it's 9.6 seconds squared. If you could forget that square, you're going to be way off. See that? Square. Make sure you square that 9.6. It's not 9.6 seconds squared. It's 9.6 seconds. Square it. And our answer is 452 meters. Again, if you watch those things cancel out, you'll be fine. The units cancel out in the step above. You'll be fine.